Okay, hello and welcome to day 5 of Advent of Code. So, let's see what this one's all about. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents, which is our puzzle input for you to review. So off the bat I can see we're getting a pair of Cartesian coordinates, an XY pair and an XY pair. So this is probably going to be something to do with sort of figuring out lines on a Cartesian plane, I'm guessing. Each line of vents is given as a line segment in the format x1, y1, x2, y2, yeah. Where x1, y1 are the coordinates of one end of the line segment and x2, y2 are the coordinates of the other end. These line segments include the points at both ends. An entry like 1, 1, 1, 3 covers points 1, 1, 1, 2 and 1, 3. An entry like 9, 7, 7, 7 covers points like 9, 7, 8, 7, 7, 7. For now, only consider horizontal and vertical lines where either x1 equals x2 or y1 equals y2. So purely horizontal, purely vertical, no diagonal lines. So the horizontal and vertical lines from the above list would produce the following diagram. In this diagram, the top left corner is 0, 0 and the bottom right corner is 9, 9. Each position is shown as the number of lines which cover that point, or a dot if no line covers this point. So you can see these two lines intersect, which is why we get a 2 here, because that point is covered twice by lines. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger, a total of 5. Consider only horizontal at how many points, so we basically need to construct a diagram like this and count how many of these are greater or equal to 2. So let me just look at what the puzzle input looks like. Okay. Got it. All right, so let's give this a go. So I know immediately I'm going to create a structure called a point. Do I want to call it a point? No, I'll call it a vector 2D, right? Because we're basically having pairs of vector 2Ds. So it's just going to have int x and y. And then we're also going to have a line, 2D line, and that's going to have a struct vector 2D. It's going to have a start, and it's going to have an end. In fact, there we go. So this is our pair. Let's go ahead and create a new document called input day 5.txt, and let's go ahead and copy and paste our example input. No, that is, why is it done that? Copy and paste. Right, save that. So I am going to read our input to begin with. I know some days we do the business logic first and then input later, but I'm going to do read day 5 input. So we know we want a file. Let me, as usual, open a previous day. At some point I think I will be putting this into our own little file reading library, maybe even today or I might do it tomorrow, because I just want this one to be a quick one, because we are starting to repeat myself a lot with the file reading stuff. Let me just copy all you. This now returns a bool. We pass in our file name. Close file. Right, so we're going to use the good old fscanf, which takes in our file. The format, if we come here, open our day 5, it's obviously it's a number, comma, number, this, and then number, comma, number, and then we're going to create our line. No, sorry, it's our struct line 2D. This is our input line, and we're going to have input line start.x. So this is going to be the address of input line start at input line start y, input line end.x, and input line end.y. And this will be in a while loop. Well, for now, I'll just say scan success. So if scan success, I want to print the line, so printf percentage %d, percentage %d, percentage %d, percentage %d, and it basically is just this, but without the address of operator. So let's give this a go. We're going to do read day 5 input, and it's going to be input day5.text. Let's compile this. It does compile. Let's run it, and 0959 0959. So this works. So as usual, we're going to define our max day 5 input lines. Say there's maximum of 1,000, and so this will now become an array. And then this will become a while loop. We then need a int input line count, while doing this, our input line count will increment. This becomes input line count. Let me just copy paste these. And then we need to do if f end of file. So if we're at the end of file of a file, we will break out of this loop. And then what I'm going to do is for int line I equals 0, while line I is less than our input line count, line I line index, and then we'll do our struct line 2D input line equals input lines line I. So we select it, print it, make sure we do a new line here, compile this. We do have, so these are now called input lines. This no longer needs to be a thing. Compile, it does compile, run it, and we can see we are successfully converting these to our integer value structures and then converting these back to our string representation. So that wasn't too hard. All we need to do now is, instead of constructing our input lines here, we are going to do struct line 2D. We're just going to call these lines. Right, we're passing our array of lines, and we also will do our line count here. Let me just move this over a bit. So this goes away. This just becomes lines. This becomes line count, but we need to remember to dereference it because it is a pointer. And this becomes line count equals 0, and then our line count, I'll just say plus equals 1. Right. So again, this becomes lines. This becomes our line count. And then here, we're going to create our struct line 2D lines max and our int line count, and we need to pass our lines and the address of our line count. Make sure that compiles and it still runs correct. Let me just go back to main and comment these out. So we are getting day 5 for now. Very good. So if we do successfully read this, let's go back to the instructions. So first of all, we only care about coordinates that are purely horizontal or vertical. And so I'm just going to create a boolean for that called is line orthogonal. And then we will basically return line.start.x is equal to line.end.x, or line.start.y is equal to line.end.y. That is, so we'll have our usual loop here. And then we'll have our if is line orthogonal. So we need to get our line.
Our line equals, say hello to cat again. Hello cat.
This is Eddie, by the way, who often likes to interrupt my advent of code by blocking vision of the monitor. But no, you can stay there. You're being good. So we need to get a line, and that's simply lines, line I. So if our line is orthogonal, then what we need now to do is to have like our grid. And we need to know how big to make that grid as well. So we kind of need to scan through all our x coordinates and find the biggest x and all the y coordinates and scan for the biggest y, so we know how big to make our map of, I'm assuming, the seafloor in this case. So to do that, Eddie, you're moving my microphone out of the way. So to do that, before we do all this, I'm going to copy this loop. And then we're going to have our int, we'll have our map width, which starts at 0, and our map height, which starts at 0. And then basically need to say if we'll also, get our line. If our line.start.x is greater than our map width, then our map width is equal to line.start.x. If our line.end.x is greater than our map width, so we basically need to do all 4 cases. So let me copy paste this. So if our start.y is greater than our map height, then our map height becomes start.y. And again, if our end y is greater than our map height, this needs to be y and this needs to be height. So that's just going to figure out what the bounds of the map is going to be. Then we need to actually construct the map, and that's simply just going to be a list of integers. So our map is just going to be map width times map height. I have a feel now that we actually can't construct it in this way. Maybe we can. Yeah, I think we still can, even though these aren't constant values. And if we go back to our coordinates, input, we do count from 0 already. So 0, 9. Like if we just consider like a one-dimensional map, if our coordinates go from 0 to 9, then our map width is actually 10 cells long. So we actually want at the end just to do map width plus and map height plus, I think. We just need to add 1 to each to account for that. Oh, what now? You know what? I might just use calloc for this. what calloc does is it allocates a requested memory and returns a pointer to it. The difference between calloc and the difference in malloc and calloc is that malloc does not set the memory to 0, where calloc does set the memory to 0. So yeah, I'm going to say int map equals calloc size of int, and then we'll do a int pointer, and then we'll just remember to free our map afterwards, right? Yeah. So then at least we know that our map is zeroed out. We don't have to do that manually. Cool. Now what? Now we basically need to run along the line. So we need to interpolate along that line and increment the numbers in each cell. So the way we can do that is by creating our vector. We're going to call it a cursor, right? And our cursor is going to start at line start, and then we need to move the cursor. So while our cursor dot x does not equal to our line end dot x, and our cursor dot y does not equal to our line end dot y. And I have a feeling we'll be I won't extract this out yet. We might want to create like an equality, our own little equality function for vectors. But yeah, so while our cursor is basically not at the end, what we're going to do is get our map index, and that we basically need to convert a 2D value into a one-dimensional index. And I believe the way to do that is, let's just validate this before I just assume how to do that. So if we had 1, 2, 3, well, actually no, this would be index 0. So if we had a map that is width 3 and height 2, and we wanted to get the coordinates x 0, 1, so the coordinates 0, 1, well actually no, if we wanted the coordinates 1, 0, which would be this one, then it's simply x plus y times width, right? Because y is 0. So let's see if that works for 0, 1. So that would be 0 plus 1 times width, which is 3. So cell index 3 is 0, 1, 2, 3. Yeah. If we wanted 1, 1, which should be cell 4, then yeah. So it's basically cursor.x plus cursor.y times map width. Let me go into this, and then we basically say map i plus plus. We increment the number in that cell. And then we need to move the cursor along. So we need to interpolate the cursor. Very easy way to do that is just to check if our cursor x is less than our line.end.x, then our cursor x needs to increment, else if our cursor.x is greater than our line.end.x, then our cursor.x needs to decrement. If our cursor.y is less than line.end.y, needs to decrement. Very good, very good. And then we basically just need to print all this out. Once we've done this, so I'm going to do map width x++. Sorry, let me move that now. For each row, wait. No, we want to swap these two. There we go. And then we're going to do our int map height again is basically x plus y times map width. And then we'll do printf. It's going to be if map, that should be not map y but map the map index for 0, then we're going to print a dot, else we're going to print the number of map I, and then for after all that we're going to just print a new line. Let me also print a new line before here. Say map, compile that. Let's see. I think we need standard lib. We're missing a semicolon or something. Expected. Oh, what am I getting wrong here? Oh. Of course. I put the pointer on the wrong side of the int. That's a silly mistake. Okay. So, we are printing the map, but this is not working. Why not? You're setting the line count correctly. Was this ever get called? I just want to see if this ever gets called. Yeah. So our cursor equals line start. Well, our cursor.x does not equal line end.x, and cursor.y does not equal line end.y. We're going to get our map I. Let me just printf what our map I is equal to. And our what our coordinates are. So it'll be percentage d cursor.x, cursor.y, and also just make sure that we are let me compile that. Interesting that our while loop. Oh, does this need to be an OR? Because if our... Yeah, I think that needs to be an OR. There we go. So it is getting something similar. Like if I let me just open Scratch here and copy paste you. Wait, I'm not going to copy paste you, but I'm going to copy and paste this here. So what's going wrong here? It looks like it's not all the lines are one too short. Because look, that line's 1, 2. We're getting 3 2s in the line here, only 2 2s here. So that's the problem, because once our lines are in the same place as the line end, we do still want to run this one last time. So we could just do that with a bool, like bool is at end equals false, right? And then I'm going to get you and say is at end equals this. So while we're not at the end, so at least we will then run run it one last time. Let me just check that works. No, that horribly broke it. Why did that break it? Oh, then this needs to be like, basically becomes an equality check. See, I knew we would need, actually, is that the only time we do an equality? So yeah, there we go. Now we're getting exactly the result we were expecting. These should match, and just at a glance they do. Very good. So let me get rid of this print, debug print stuff. And then let me have a look at what the final result. How many points? At least 2 lines overlap. So to do that, very easy. Once we've done all this, we basically just need to loop through all our map points. So that's going to be map width times map height. Overlapping, I'm going to call them cells, equals 0. And basically if our map at that cell is greater than or equal to 2, then our overlapping cells can increment. And then we finish with the map now, so we can printf day 5 number of overlapping cells is %d, new line, overlapping cells. So again, let's just check it. Day 5 number of overlapping cells is 5 and total of 5 points. So let's now get our puzzle input. Let's open our day 5 input. We are going to delete this, paste our puzzle input. We're going to compile and run it. I might have to make this bigger because there's just going to be so many more. So we can see it's reading our input correctly. We're getting towards the end now. Here's our map. Our map's huge. But yeah, so these are all the thermal vents. Let's keep going down. The number of overlapping cells is 5092. That is the right answer. So I reckon it's now going to be diagonals, right? Unfortunately, considering only horizontal and vertical lines doesn't give you the full picture. You also need to consider, yeah. Because of the limits of hydrothermal vent mapping system, the lines in your list will only ever be horizontal, vertical, or a diagonal line at exactly 45 degrees. Aha. That's quite good, actually. I thought we'd have to look into something like the Bresenheim, is the Bresenheim line algorithm. Bresenheim line drawing algorithm for like lines at arbitrary angles, but I don't think we do need to look at this. Maybe in a future day we will have to come back to the line stuff and do something more complicated like this. But because it's only 45 degrees, I think our logic still holds. So let me get our example logic again. Let me hide this. Paste you in. I want to see if I just get rid of this line, say if true, does it still work? Let's find out. Looks like it does. Let's open our Scratch and let's paste the example they gave us here. And yeah. So we didn't even have to change a line of code for part 2. Well, other than this line, obviously. But we didn't have to add any extra lines. So I'm just going to get rid of this, and this. We can get rid of this function now. We don't need it. I'm going to get rid of these. We don't need to print. We know, oops. Our reading works. I'll keep the map in because it's fun. And let me just open our input day 5. Let me delete you. Go back to our input. Paste it. Compile and run. So if we look at this, you can see we're getting diagonals too. Whoa. It's quite fun to look at. 20,484. We did it! Boop, boop. So that's day 5 done. And in about 135 lines of code, which isn't too bad. You know, it was a fairly tame one today. Actually, I'm doing this 2 days late. Oh no, a day late. It's the 6th now. So I probably won't have time to do day 6 today, but I might have a chance to do it tomorrow. But it does mean I'm going to be lagging behind by 1 day. Hopefully I've got a day off this week where I can catch up. Cool. Yeah, thank you so much for watching again. Goodbye.